Hi everyone, Masudi here.
Hi guys, welcome back.
So last session, I remember we had a problem with our code, and we were trying to test the HTTP connector that we refactored, and we had a minor problem there, and we decided to solve it in this session. But before solving that, I just want to convert our project into a Gradle project. So this project is now being the build and the creation, not the creation, the building and producing jar files and run files, and we click here and it runs, and all this stuff is being handled by the IntelliJ IDEA and the build tool. So for building a project, most of the times we are using a build tool, and we are not even aware of that we are using some kind of tool. So for example, when you are using the Eclipse IDE, most of the times it is using Ant build tool behind the scenes, and you are not aware of that. And also, this project here is a simple project. The build and all automation is being handled by the IntelliJ IDEA itself for you. And for adding a simple dependency file like the Json file, we have to actually go all the way to manually to the repositories ourselves. For example, to Maven Central, search it, download it, and then bring it here, add it to the class path of the project actually to make it work. But and most of the time, the dependencies that we are downloading, have other transitive dependencies themselves. But we were actually lucky that the Json dependency was a single jar file, and we just downloaded and added to the project, and it was very simple. But this session, we are going to use a bunch of, widely used HTTP clients that mostly the Android guys, developers use nowadays. For example, like Retrofit, especially the Retrofit and the Volley. And we are going to add it to our project and use them against our own server and a fake online Json server, just to see that our HTTP client is actually working, and also get to know other standard and well-known HTTP clients. So as I said, the Gradle is a build tool, and is the widely used nowadays, is the best build tool out there. And a build tool actually handles your dependencies. And also, you can have multiple projects, in one project. You can actually divide your project into multiple projects. The big projects actually do that. And you cannot do this with a good build automation tool like Gradle. So let's do it manually. Actually, I want you to see. So this is the structure of our project. No, sorry, this is the one. This source folder is RC folder, and this file actually was built by us. And this is the repository and the serialization of the repository. This IML file is the one that the IntelliJ IDEA uses to actually know that what is the name of this project and other stuff. This out is the build folder. When we build our project, it is built here, and it has a lot of .class files it will be having, and the Git is actually the Git, and the IDEA itself is the one that the IntelliJ IDEA is using for other things. So it's a Gradle project actually has a build. Actually, we are not going to create a multi-project Gradle project. This is a single project. So we need a text file actually as the script, as the build script. So I'm going to actually rename this shop. I'm going to erase the content and use this. So a standard build script, a Gradle build script is build.gradle. And the great thing about Gradle is that you can actually write with Kotlin programming language, the one that we are learning here. So there are other build tools like Maven, like Ant, like Ivy, like other tools that are based on just XMLs. You cannot write anything but XML on them. But in Gradle, you are writing actual Java, Groovy, or Kotlin code. So if we say KTS, Now let's get rid of this. Let's get rid of the content. And let's go to the Kotlin website. In the get started part, we have this working with build tools. So if we just get started with the IntelliJ idea without using any build tool, and now we want to use a build tools. So with build tool, we have these options, Ant, Maven, or Gradle. And these two are, and this is the most recent one, the Gradle that we are going to use. These two are based on XMLs. So with Gradle, actually you simply have to add plugins in the build script. For example, if you want to have an Android project, you just add the plugins and it handles everything. It adds the dependencies, it downloads the dependencies, everything. It adds the, a single button to create an executable APK and all of that. So for Kotlin, it is just suggesting that we copy and paste this plugins, JVM version 1.4.21, which is the most recent one here. And we add it here. And then we have to say repositories. Actually, we have to point to some server that we are introducing some server for the Gradle to download the dependency files, all the jar files. This JVM, this plugin has a lot of jar files, to download. We can do something like this, Maven URL, and for example, say that give the website of the, for example, Maven Central or some other server that provides the dependencies. But if we say, if we call the Maven Central, central function, actually I'm writing Kotlin code here. This plugins here is a function that receives a lambda as the last parameter, that because it's the last one, we can bring it outside the parentheses. And because the parenthesis is empty, we can get rid of that. And this Kotlin again is a function, receives a string. Then you don't see a dot here because we've not learned about the infix functions. We can have infix functions. Actually, it is reading like something that it is not Kotlin at all. Everybody can read this. The first purpose of the script languages, DSL, domain-specific languages like Kotlin, is that you can create some kind of API that hides the Kotlin, everybody can read it. So we are saying the repositories that you will be using is Maven Central, and just that, I think it is just that. And if I open a command line here, because I have the Gradle tool I've downloaded, you can download it from here. Let me show you. Gradle.org. Install Gradle. The most recent one is 6.8. All you have to do is to download this binary or complete version, copy and paste it somewhere. For example, I've copied here. Let me show you. I have it here. It has a bin file as we expect. If we add this bin file to the environment path, we have access. For example, let me say Gradle-version -6.7.1, and I have access to that. And because we are in the path of the project, shop tutorials here, let me show you. And we have a build.gradle here. If I say Gradle build, it will try to download all the dependencies and build it. Actually, the build was successful. And it downloaded everything behind the scene because I had downloaded before with another project, it just downloaded very fast. But you will see that we will be adding a lot of dependencies, and it will download it for us, and it will add it automatically to our project, to the class path. So the Gradle, the Kotlin plugin that we added here, actually expects that the code will be in the source main Kotlin folder. So we have to create source main, and inside main Kotlin folder, and we have to cut and paste our code inside the Kotlin folder. And if we get back to the project, we will see a hint here that it is seeing a Gradle build script, and we asking us to load it as Gradle project. We click on this, and it actually starts indexing everything, importing this project as a Gradle project, not as a simple IntelliJ IDEA project. So it is importing, it is indexing. It will take a little time, a bit of time for downloading all the dependencies, indexing them. Actually, you can see here that it is downloading some dependencies there. Okay, I think, let's see. Okay, the project is imported again as a Gradle project, but as you can see here, we have a problem here. It is not recognizing the JSON library, the JSON package, because this time the project has been imported as the Gradle project, and the Gradle project has to handle its dependencies itself. We cannot rely on the IntelliJ IDEA and go and add manually dependencies here ourselves. We cannot do that, because if we sync it again, if we try to build it again, it will get rid of everything that it is not included in the Gradle file. We have to include it into the Gradle file, and it will tell the IntelliJ IDEA, and it will introduce to the IntelliJ IDEA. So if we open the Gradle file, the script file that we have here, we wrote it. We don't have any dependencies yet. We have to add a dependencies section. Inside the dependencies section, we can say, I want to add in the implementation phase of my project, I want to add, let's go to the Maven Central. This time, instead of downloading it manually and adding, I just want to give the address of this specific artifact. They say it artifact, a jar file, for example. I want to give the specific address of this artifact, of this library, to the Gradle, to my Gradle tool, and it will ask all the repositories that I have given for this artifact, and it will download it from the first that it responds okay. So the address consists of 3 parts: the group, the name, and the version. The group is actually the name of your organization or your website or something like that. For example, you are someone that write a lot of libraries, and you have a website, and you want to be recognized globally that this is your library that you're writing. So you will, for example, use your domain, your website domain, because it's unique, as your group. Then the name is the name of the artifact. For example, you have 10 libraries. You have named one as JSON, named one and as another thing. And the version, of course, is the self-explanatory one. That, for example, for JSON library, you publish updates, and you give some kind of version. And versioning is everybody do the versioning, their own way. For example, the JSON library uses the year version. For example, 2020. September or November, I think, 15th of the November 2020. Others use, for example, 1.5, 3 point, for example, something like that. Minor.major, major.minor, for example. Versioning is something that is not optional. You can do it your own way, and you have to explain it. What does the numbers mean? So the group is org JSON, and this is the version. We can copy and paste it. I want to write it. So we can say org.json. This is the group, separated by a colon. JSON artifact, we want the JSON artifact, and colon, then this version. And if we refresh, I just want to show you that. It is downloading the JSON file. It downloaded because then it adds to the project, and suddenly everything is resolved. The dependencies, everything. And if we go to the project structure that we add manually before, I think we should see, yes, this is the one, Json. It just added it automatically for us. If we add it here manually, and if we run the project again or sync the Gradle project, it will remove it from here because it is not being included in the Gradle script file. And actually, it downloads these dependencies going through all the repositories one by one. We have only one here, Maven Central. And because we know that this is accessible in the Maven Central repository has it, we confidently give only one repository. We can give multiple repository. So now let's get back to the project. We had a problem last session. Let me run the admin. And the problem was that when we tried to connect to the admin project, to the server, and ask for the product list, it was sending the get product list, the request URI, as the method, as an HTTP method. And the problem is because of course, let me show you here. So the request that we are trying to send here, actually we are sending place order as the method. You can see it here, not as request URI. Actually, this is wrong. The place order is the request URI. The resource URI. Sorry, this is the resource that we are trying to access on the server, not the method. The method here is get, post, delete. So we have to cut it and paste it here as the request URI, and asking for the place order. Let's say we will send it as post, and also we have to correct this. For getting the product list, let's say we will use get. Most of the time we use get for the things that we just trying to ask from the server. And we use post method as actually changing someone or creating something in the server. For example, we are sending something to the server and we want to change something there or create something new there. And these are, protocols between the server and the client. If the server can decide that I'm going to use get HTTP method for everything. And actually it will use this protocol wrong, because when you read the protocol RFC, you can see that it is recommended that you use post and get, and for this sub problems, not for example, don't use post for getting something from the server, although you can do that, although the server can give you everything with the post request. But most of the time, when those guys that are the back-end developers, this is the back-end developers' job, that are creating HTTP endpoints for the client-side developers, client-side, for example, for Android developers, they say you have to, for example, send post and send these headers actually to, for example, create a user. You can negotiate and say that I'm going to send a get, and the backend developers can accept and write it in a way that they will receive a get, not a post. So let's run the customer actually to see that it is working. Let's ask for product list, and it is receiving the product list because we get rid of the shop.txt file. We don't have any product. Let's create some products. Creating product was 1 apple, 100, again 1 orange, 500. Now let's get back to the customer, ask for product list, and we receive the product list, and the response was 200. So the HTTP connector is working. Actually, we are using our HTTP connector, HTTP client, against our own server, and we want to prove it that it is working correctly, actually by asking and issuing requests against other servers. So I found this. There are a lot of fake JSON servers online out there that you can send JSON, create JSON, and get JSON just to test your, for example, HTTP client, just to see that it is working. So this is a backend here, the JSON bean.io in this machine, in the port 80, of course, because we've not said that in the port 80. So this is the machine. It has an IP address, and there inside this machine, there is a process running an HTTP server on port 80 that we will be addressing and creating some JSONs and asking for JSONs. So for creating a JSON in this server, you have to first log in, create a user, and then inside the API keys, you can get your API key here. This is the API key because they want to recognize you. And then you can create some JSONs and ask for JSONs, actually to play with HTTP protocol. So let's get back here and let's get to the API reference. Inside the API reference, we can see that for creating a JSON as some kind of document here, we have to give this address as the host, give this as the resource URI. Then they are asking as the request method, HTTP method, they are asking for post, actually for creating. You can see this pretty standard, pretty much standard. And it is requesting some headers. It is saying that headers are, of course, key value pairs. For example, it is asking the content type header as application JSON, and it is saying that it is required. The server will require it. And if we don't send it, it will, for example, respond 400, bad request, for example. We can test that. Also, it is asking for header named with a key secret key and with the value of our own secret key, and it is again compulsory. It is the other ones are optional, and we don't want to get through them. And here it describes the headers more, and then it shows some example. And we are going to use this actually with our own HTTP connector. Let's get rid of this part here. This is a simple file here, and I'm going to use our own HTTP connector. HTTP connector equals new HTTP connector. This is the one that we have, and we want to send an HTTP request and receive an HTTP response. So the HTTP request, val request equals HTTP request. This is the API that we wrote it ourselves.
Yes.
Ourselves here. So HTTP request, the one, okay, let's get rid of this wrong import that we had and add the one that, because we have two HTTP requests, we want to use the one that we wrote it ourselves. So as we wrote this API ourselves, an HTTP request is asking for a host, port, method, request URI, headers, and the body. So here we can see that the host is this one. The port is, of course, 80. The route here, the resource URI is /b, because that server is asking us to do it that way. The method is post. We can go back and check it is post. The request URI is /b. We don't have, we have a bunch of headers, of course. So headers are map. Let's say map of, let's create a map here. We will fill the map later. And the body is a JSON that we are going to send. So let's make it a multi-line string here. And then let's send the request and ask for a response, which will be an HTTP response. So the header, let's get back to the headers. The headers, we had two compulsory headers. We have to give content type as application JSON. So content type 2. You've not seen this 2 before.
Yes.
Application /JSON. 2 is a function, and you don't see any dots here. It's actually this dot. This is the equivalent of that. So we can write infix function. Let's see that's real quick. We have a font, for example, plus, for example. And we have to actually first define some class number. Let's say we have a number class, and it has a function plus, yes, that receives another number. No, another number to plus it. Number. So if we create a number object here, yes, we can call this plus function and give another number to it. For example, to make make a plus. There is a special modifier here as infix. You can add it to the functions. And infix functions actually have to have only one parameter. They cannot have 0 or more than 1, just 1 parameters. So you can call infix functions like this. You can get rid of dot and get rid of the parentheses, and it will read very perfect. Number plus number. It actually just helps for reading the code better. For example, you have, let's see, 2 dot. Let's say you have added this number to some kind of local variable, number 1, and this one to another local variable. And you can see that number plus number 1 reads very well, reads better than number dot plus number 1. We are actually calling a function behind the scenes, but Kotlin helps us to read, make the code read very well. Readable. Yes, make it more readable actually. And this 2 here is a function on a string that receives another string and gives a pair. Content type and application/JSON. And this function receives a bunch of pairs and returns a map of a string on a string. But to make it more readable, we convert it to this, because this 2 function will return a pair. You can see that will return a pair here. And then we can see that this 2 function is infix function, and we can get rid of this dot and this parentheses. And the creating of a map is very readable. Map of this to that and this to this, for example, something like this. Another header is secret key, yes, to our secret key. And our secret key was, let's go here, see what is the secret key. This is our secret key. Okay, so these 2 headers are, this server could ask these stuff in the request URI. It could ask these stuff in the body. For example, it could ask it, send it in the body. But it is asking to send these things in the headers and the other things in the body, in the payload. So as we said before, you can send your information, your data to an HTTP server either in multiple places. You can send it in the URL itself, you can send it in the headers or in the payload body. And this is something that the back-end developers will negotiate with the client developers, and they will ask, we are expecting these things in the headers, these things in the body. So these are the headers. We are doing the post. Let's get rid of this message here. On port 80, this is the machine host. And the body, let's send some string. Let's create a JSON. For example, name MassOD age number 30, for example, is married, for example, false, a Boolean, or for example, other kids, let's say friends. Let's create a JSON array. Omid, for example, someone else. And this is a standard JSON here. This is a JSON object, and it has 4 key value pairs. This one is receiving number, this one Boolean, this one string, and this one a JSON array. So let's connect and see what will happen. Actually, I'm very excited. It's the first time. Let's get rid of these extra stuff. Unknown host exception api.jsonbean.io. Unknown host is not able to. Maybe let's get.
We didn't add that dash on.
No, we added.
Slash
we added. Oh, it's so it's HTTPS. This website is HTTPS. You can see. And we are implementing HTTP, actually creating an HTTPS and supporting HTTPS protocol. It has another RFC file, and you have to support negotiating keys, secret keys, and then negotiating the, because the connection to the server is encrypted. So you have to first negotiate a key and then encrypt your stuff and send it. We cannot use this. Let's see if the server, I don't think that this server supports HTTP. I don't think. Yes, it is an HTTPS server, and we cannot use our own API, the HTTP connector for that, because we have not implemented the HTTPS protocol yet. So for using let's add other standard HTTP clients and try to connect with those, and then we can try to connect to some HTTP server with our own HTTP client. So we have the Retrofit here, or the Volley. Let's first go with the Volley. I don't have any experience with none of them. I've seen Retrofit before because I was an Android developer once. So the Retrofit, the Volley here has 1.1. This is for July 2018, I think. What was the last version that you used?
I think that's the last version.
1.1.1, yes?
Good.
So come android.volley.
I think it's more than the. You can Google it.
Let's go with the Retrofit.
That's Volley. Oh,
This is Volley. Let's go with the Retrofit. So Retrofit, the last one is 29. This is for May of 2020. 290. Come dot. This is for Square Company. So for adding another dependency, we simply just have to come here and say, add this as in the implementation phase of my project. Implementation, yes. This is the group. The name is Retrofit, and the version is 2.9.0. Retrofit 2.9.0. Let's ask for download. It is downloading Retrofit and a lot other things, OK HTTP and other things. Because if you see here, it has other dependencies itself. It has a dependency to OK HTTP. And if we wanted to download and add it manually, we had to actually add this one as well. And actually, if we go to this one, you'll see that it has other dependencies. So the dependency has other dependencies. Those dependencies has other dependencies. We have to go and download all the jar files and add it to make it work. But the Gradle will download the transitive dependencies for us, and it will add to the project. And if we go here, I can prove it to you that it has added Retrofit, OK HTTP, OK IO. We didn't ask for these things. We didn't ask for them. We just asked for Retrofit and JSON. But in the Retrofit, we needed this OK HTTP, and the OK HTTP needed OK IO, and it downloaded and added here for us. So actually just leave it as is and create another file for test retrofit class, not a class, let's create just a main function. With retrofit, as I remember, let's search for retrofit 2 example. Let's see.
It works with annotations.
It works with annotations. Yes, we have to create an interface, and it will implement the body of those for us. Something like this. We will say get, for example, do a get or do a post to, for example, this URI with these headers and return a list of something. So it says that go ahead and add these, and then for the setup, we have to create an interface and say that this is the function, these are the query strings, and for setting up, we have to say retrofit builder dot base URL and dot build, and we receive a retrofit, and then we can ask for create. Okay, something like this. First, we have to say retrofit dot builder dot base URL. We can give a base URL. Let's give this actually, because we are going to test everything against Json bin.io HTTPS. Let's give this as the base URL. We can give the URLs on the annotations that we will be seeing later, but because all the requests that we are going to issue is against this only single server, just let's give it here. And I think if we say .create, let's copy and paste everything here, because I don't have much, and it is not necessary to have experience with these things, because once you know that how an HTTP client is working, all you have to do is to go and find, for example, a standard, most widely used HTTP client out there and see how it is being used. Just simply use it. So we say build. We don't need this converter factory. Build, not create. It will give us a retrofit client, I think, something like that. Then we can ask this to create. Yes. So how this retrofit thing is working, actually, it has a lot of things is going on behind the scenes. We will just only create an interface like this. Interface. For example, it was JSON bin. Yes, JSON bin IO endpoints. Let's name it this. For example, say in the JSON bin IO server, we can issue a post. Let's create a function first. This is an interface, a Kotlin interface. A Kotlin interface has a lot of functions without bodies. So fun, let's say create new, let's name it create new JSON, yes? Then we are going to give an annotation, the post annotation in the retrofit library. So in the post, let's see, we can give the URI. I'm going to give /b because I remember that.
Yes, it was
/b, yes? This is the get. Let's go to create. /b, yes, a post, and these are the headers, the compulsory headers, content type and secret key. Let's see how we can give the headers. Actually, I'm not seeing, maybe with another annotation header, or yes, we have a header annotation here, header.
So we had headers.
Also we have headers. So header annotation will probably will get a key value pair. Let's get, oh, we have header, and we can ask for header here, and we can give the header in the yes, and query string we can give it here, and retrofit to header, add custom request header. header. Yes, we can give it like this, headers. Retrofit 2 with the headers, not the header. Headers. And this will be content type is application JSON. And let's see, yes, it's a var arg. We can give other headers. And other one was secret key with the value of our secret key here, which was this. Copy, paste it here. And we have to get rid of, because we have dollar signs, yes. Let's see if we can give multi-line string in the annotation. Yes, we can give it. It is converting actually, and we don't want it to be converted. This will be secret dash key, and let's surround it with 3 quotations, see what happens. Because we have dollar sign, we have to escape it with another dollar sign. Dollar sign has to be escaped. I think it has to be escaped with another dollar sign, or if with a backslash or slash, 2 backslashes. I've forgotten how we can escape a dollar sign. Let's search for that. Kotlin escape, because dollar sign means something in the inside. Escape dollar sign. And
backslash.
Backslash? No, backslash wasn't working. To escape a dollar sign inside screen reader, I'll use the backslash character. I used backslash and it didn't work.
With quotation, I think, huh? Or no?
No. Nope. It is not working. Let's make it 1 quotation. Oh, it is okay inside 1 quotation. Okay, so we have content type, secret key, and post to this URI. We don't need to send any query strings with the URI, and it didn't ask for, let's see, it didn't ask for, oh, and it needs body, yes. We are going to send our JSON in the body. So let's see how we can send stuff in the body. So again, we have to search. Actually, this is nothing to be ashamed of, because as I said before, we know that what are these things are doing. We wrote it ourselves with socket programming, you know, from very basic stuff. And now we are just going to use someone else's library that will abstract these details away. After actually we know, we have to use these abstractions after we know what is going on behind them, behind the scenes. We are not allowed to use all these abstractions and think that some magic is, you know, there's some kind of magic going on. So retrofit 2 body payload, post body JSON. Let's see how it is done here. We have post @ body. Okay. If we say this is an @ body and we give string content, for example. Oh, sorry, I have to put, it's not Java, it's Kotlin. Content string. With this annotation here, we are telling this retrofit that use the content that I'm giving you as the body, as the payload of this request that you are going to send. We can write other headers here. For example, maybe one header has a value that will be determined in the runtime. We can add header here alongside this, along this body here. And you can see that we didn't wrote anything. We didn't wrote the body, the implementation of this function. And we are going to ask the retrofit for JSON bind IO endpoint interface. I have to give the Java version because it's been written in the Java. I'm just referencing to this JSON, to this, sorry, interface. I'm just referencing to this and asking Retrofit, please implement all the functions here as I described it with the annotation that you provided to me. You've provided these annotations to me to actually declare. I'm declaring that I want this to connect to this endpoint with these headers, with this body, and I don't want to implement it. I don't want to implement the socket implementation, connecting, disconnecting, everything. It will create an instance of, it's very funny, an instance of this interface. It will create and return, let's name it endpoints. Actually, I can prove it that it's JSON. So you can see it is returning an instance of this interface. Actually, it is extending this class, implementing all the functions, creating an instance and returning to us. Doing everything. These are boilerplate code, boilerplate stuff. Boilerplate means that these are the things that you know what is going on behind the scenes. You know everything, and you don't want to write them every time yourself. You don't want to open a socket and get to, for example, all those things manually again. So there's endpoints, and because we have only one function here, we can call it create new JSON, and we can give a string. It asks for a string. Yes, let's give it one. For example, I'm giving a JSON in the string, name mass od. Let's see what will happen. Let's run it. And it is saying that could not locate request body converter. Oh, we have to give a converter for the body, and we didn't give it here. And I remember that there was, in the builder, we had add converter factory. And for the converter factory, let's see what are the standard ones that it is providing for us. Built-in converters, dot. Let's search for it. Retrofit string converter factory. So Json converter, I'm not going to use those. Oh, maybe we have to add this to the dependencies and use, for example, Json and Json, and we don't know these tools yet. Json and Json are for serializing an object into JSON and deserialize it back again. So automatically, but again, we have to do it manually to see what is going on, and then we can use these tools. So let's add this. Let's get rid of this. Come to the Gradle, almighty Gradle. Ask it for, of course, 2.9, because we have this. Ask it to download. It will download. It is downloading all other dependencies, and then we can add, let's see, it was Json converter factory.create. Json. I don't see that. Json.
It's smallest.
No, this.
G is capital, S is small.
Scholars converter.create. No, we didn't add we add the scholars.
Yes.
Not the
Json
one. Let's see what this one does. Maybe this one will do the job. Scholars. Run it again. And hopefully it will connect. Service methods cannot return void. We have to return something. We are returning void. Let's return string, for example. Let's see what is the string. This string will be the payload, the body of the response. So we can print this. So let's say val response equals, and let's print ln that response to see what is that response. Run it again, and could not locate call adapter for class. Unable to create call adapter. Json bind that create new JSON. Let's see. Let's search this. This is something that happens most of the time when you are using someone else's library, because you have to know every bit of unable to, because this is their library. They have implemented this. Short answer, return call simple in your service call. Call simple. Okay, let's return call simple. From here, not a string. Call, maybe string. Call is another class in the Retrofit library, and we are asking for call. Call will have a lot of, we cannot print it. Call have a lot of, useful functions. Okay. I think it is done. Let's get it here. Let's get back here to our library, to the server, and check.
Go click your picture.
My
click
picture.
it, then dashboard.
Yes, go to the dashboard, and we have released. I just see only 2, and these are the ones that.
These are the old ones.
Yes, we created before. And let's see in the response what is going on in the response. Response dot. And maybe we have to tell it to execute. Execute. Then it will return a response string. Let's rename it to call. Val response equals call.execute. And inside the response, we will have response dot body code, of course, headers raw. Let's see what is the code and what is the message. 404. We are receiving 404 code because we are accessing server in the wrong way. JSONbean.io / let's get rid of / here. Get back here, /b post. Let's run it again. Actually, it seems fine to me. 404. Why? JSONbeans /b api.jsonb.io. Oh, API. We missed the API dot. API.jsonbean.io. Let's run it again. We got 200.
That's okay, I think. 200
yes, 200 is okay, I think. And if we refresh here, come on.
Too many tabs are.
Come on, what is it?
They're killing their RAM, I think. That's
what's happening? Come on.
You can click on your picture again. Go to dashboard.
No, it's doing the same thing. Oh.
Maybe something happened with the internet connection.
No. No, the connection is okay. Let's go to Google actually to check that video. Oh, okay. We are back. This is the third one.
Yeah.
And
This the toppest. Oh.
And the name is Masudi.
Oh,
Please send this name Masudi.
Hooray.
And let's get back. Let's get it back from the server. For getting back, let's create another one. Fun get my JSON, for example. For getting this one, we have to go to the API, and in the read section, we can see this is the
just host. Get is enough, I think.
No, we have to append this to the URL. Oh. This route. And then we have to issue and get. We have to send secret key. Actually, let's experiment. Let's get rid of this secret key, or make it wrong to see what happens. Let's get rid of this. See what happens. Let's run it again. We are receiving 401. 401, if you go, you'll see that 401 means unauthorized. The server could send 404, 405, I don't know, 1000. It could send anything, but it is sending, standard messages. And this is something that the server will tell you. The author, the backend developers will tell the clients, the developers of the client side, that I will send back 401 if you don't give me the secret key in the headers. We can write another one and do a get to again /b and /. This time it is not asking for the ID of the document to be sent as header. It could ask to send it as header, for example, with the ID key. But it is asking to append it to the URL. And as I said before, we can send information to the server either in the URL or in the headers or in the body. We can use these three parts. And this is something that we will negotiate with the backend developers. They are asking us to send it here. And the bean ID, the thing that we just created last time, this is the ID. And we have to append it to the URL. And you might ask that, okay, we are hard coding it here. How we can send it to this function and append it here? There is ways in the Retrofit for doing that. And I'm not expert of Retrofit. We can search it and to see how it is done. But just for the sake of this example, we add another function here. Again, we have to send the secret key header, but not the content type. It's not necessary because we are not sending anything to server this time. We are receiving. We can send it and it will ignore it. And this we are asking for string again. We can ask for JSON for other things, and it can use the factory, the converter factory that we gave, trying to convert the receiving content to that. Actually getting rid of, again, boilerplate code. But you have to do these things manually first to see what is going on and then use these for example, Json converter. And ask it, okay, give me, here, let me show you. Give me a user, I don't know. Say we have a user class here. It has name, age, some properties like this. And we are receiving a JSON that the keys in the JSON object matches the key here. We can ask it to try to convert it and instantiate it to that again for us and get rid of the boilerplate code there. But again, we have to do it first manually to see what is going on behind the scenes. So this one was for creating one. Let's ask for, now you can see we have two functions implemented for us.
Yes.
We are executing the code, the message, and let's also print the body. Let's run it. We received 200 and the body that we just gave it to the server. And we are able to connect to the server with this. I think it is enough for this session. It was a long session.
Next session we can work with
Next session we will work with Volley, and we will use the Retrofit and Volley trying to connect to our own server. We were actually unable to connect to the other servers with our own client because we couldn't, yes, we didn't, we have not implemented the HTTPS yet, and it has a lot of job to do to implement HTTPS. It's not as simple as HTTP. But we will actually use these clients against our own server to prove that our server is working, and we will try to connect to HTTP servers with our client to prove that our HTTP client is standard and is working.
Thank you very much.
Yes, thank you. It was a long session. Yes.
Thank you. Good job.
Bye.